Hello friends, in this tutorial we are going to learn how to find the square roots of a complex number, and we are going to use the simple geometry to find the square roots of the number. So we're not going to use here a formula, but we will go through the drawing or geometry to solve the problem. So let's get started. We will take an example to clarify it. Let's take a complex number which is 8 plus 6i. So let's draw the axis for the complex number. This will be the real axis and this will be the complex axis. So the overall complex number can be plotted in a complex plane. So for real part 8, we will go to 8 units to the right, then we will go 6 units up. This will be 6, and since these are the perpendicular axis, so it will be 90 degrees. Let's draw the hypotenuse over here. So since this is a right angle triangle, we can use the Pythagoras theorem to find out the hypotenuse, which will be equal to square root of 6 squared plus 8 squared. So we can find it to be 10. Now let's draw a circle like this such that it touches the maximum point here. Then from the figure we can see that this is the radius of the circle, so this will also be the radius of the circle with 10 units. Now the main trick behind finding the square root of complex number is to see the length from this vertex. So this is the vertex where there is right angle, so we are going to see this vertex, and the distance from here to the left side of the circle will be 18 distance, since this is 10 and this is 8, and the distance from this point to the leftmost portion of the circle is simply 2, because from here to here is 10 and from here to here it's 8, so 10 minus 8 is 2. So these two numbers will give the real and imaginary part of the square root. So the first step is to get these distances into half. So 18 divided by 2 is 9 and 2 divided by 2 is 1. Then we will find out the square root of these two numbers. That is, square root of 9 is plus or minus 3 and square root of 1 is plus or minus 1. Now we need to look at the sign. Since this figure or this triangle is formed in the upper part of the section, or it is formed in the upper part of this axis, so it will be positive, or in other words, the value of b, that is 6, is positive, so it will have the same sign. So the answer will be plus or minus 3 and plus or minus 1i. So taking positive sign, the first root will be plus 3 plus I, and the second root will be taking negative sign, minus 3 minus I. So let's check whether it is correct or not. Let's find out the square of 3 plus I squared, which will give a square plus twice ab plus b square, and that will give a plus 6i, which is a question. And also let's check for minus 3 minus I whole square. It will also give the same result, so which is correct. Now let's do another example where the triangle won't form in the upper part of the circle but in the lower part of the circle. Let's see another example. Z equals to minus 5 minus 12i. So in the complex plan, let's draw these values. We'll go 5 steps to the left and 12 steps down, and we will form a right angle triangle like this, and we will draw a hypotenuse. Then since this is a right angle triangle, we can find the hypotenuse equals square root of 5 squared plus 12 squared. That will give us square root of 169, which will be 13. Then as per the previous example, we will draw a circle like this. Then we can see that the distance from the vertex with right angle to the leftmost portion is distance 8, because this is distance 13, and since this is the radius of circle, the distance from here to here is also 13, so 13 minus 5 will give 8. And also the distance from this point to the rightmost part of the circle will be 13 plus 5, which will be 18. So these two values will give the square root of the number. Now applying the same process, we will find the half value of these numbers. 8 by 2 is 4, 18 by 2 is 9. Then we'll find the square root, that is square root of 4 is plus minus 2, square root of 9 is plus minus 3. Then for sign there is a small difference than that of the previous example, since the triangle thus formed is in the lower portion of the circle, or it is below this axis, or in another words the value of b, that is minus 12 in this case, it's negative, so we will change the sign. That means we will change plus minus into minus plus. So the required roots will be, first taking the upper portion, that will be minus 2 and plus 3i, and the second root will be plus 2 and minus 3i. So checking the result, we will square this number to get a plus b whole square, and by further simplification we will get the same result. And similarly in the second root also we will square this number, and which will be expanded like this, and we will get the same result. So this is how it works by using geometry. But what is the mathematics behind it, and why does this work? So let's go to the algebraic version of this method. Let's, instead of working with the example, let's go to the complex number equals a plus ib, and let's go to the same method that we used before. Let's draw a plus ib in this plane. We will go a distance to this part and b distance to the complex number axis. Now we will draw a hypotenuse like this, and using Pythagoras theorem we can find the hypotenuse equals to square root of a square plus b square, like this. Then we will draw a circle. Then since this is the radius of circle, so this is also the radius of circle, which will be square root of a square plus b squared. Now we are going to find out the distance from this vertex to the leftmost part and this vertex to the rightmost part of the circle. So the distance from here to here will be this length plus a, so it will be square root of a square plus b square plus a, and the distance from here to here will be simply the square root of a square plus b squared minus a. Now in our method what we did was we first divide by 2, so after dividing by 2 we will get this result, and then what we did was we find out the square root. So taking the square root we will get this result. Then to look at the sign we can just use the simple idea, if b is positive, or if the drawing is formed in the upper portion of this axis, then we will have the same sign. That means the both of them will be written as plus minus and plus minus. And if b is negative, or if this figure forms downwards, then we will take the opposite sign. Taking opposite sign means we just change the plus or minus symbol as minus and plus sign, and this will be the two roots of the equation. And by algebraic derivation also we know that the roots of complex number are also given by this formula. So instead of remembering this formula as a whole, we can just simply use the geometric method to calculate the roots of the square roots of the complex number. So thanks for watching.